Hey, it's me, Steve. It is May 7th, 2017. Time is 9:25 out. It's 47 degrees Fahrenheit. It's been a very busy weekend. It's Sunday, and I'm on my way to Chicago to help somebody move their stuff into storage while they get their floors redone. And I've spent this weekend training my pool to get that abomination out of my yard. And I took my second oldest cat to the vet, Lilith. She had a really bad eye infection. She may lose the eye, and I'm really upset about that. But anyway, this is going to be a Geo-Rant. I'm going to start getting away from the technical stuff. The only reason why I did the geology protractor thing is because someone asked me about how we can make predictions in geology. I want this series to be less technical. That's why I do it in my car while I'm driving, to keep my compulsion to showing visual aids down to only when necessary, things like that. But anyway, today's Geo-Rant is going to be about the Snowball Earth Hypothesis, specifically the Neo-Proterozoic, or the one at the end of the Cambrian, supposedly. Okay, well, I need to give some background here, because there's something that throws a big, huge monkey wrench into the whole Snowball Earth thing. Okay. First of all, I recently, at the end of last year, published a paper redefining the Jacobsville Sandstone as Jacobsville Group, which consists of 5 formations. The basal, the Lance, is probably equivalent to the upper Frida of the Oronto group, because there's an unconformity on top of it. The other 3 layer cake ones, if you will, I don't know if you've ever heard that expression before, are equivalent to the Bayfield group in Wisconsin, but Jacobsville takes precedence over Bayfield, so that's been extended to Wisconsin from the UP. And then there's there's a fault called the Keweenaw Fault, and there's a proximal conglomerate sandstone deposit, which I have labeled the Jackson Formation. All right, so, and the Jacobsville group is all fluvial river deposits, that alluvial fan type fault proximate deposit, and maybe some minor lake deposits in it, but doesn't seem to have very many. In the middle formation of that layer cake, that seems to be mostly aeolian or wind-blown deposits. So, and Dr. Malone, in 2015, I believe it was, wrote a paper where he took over 2,000 zircons from the Jacobsville. People have taken zircons from the Jacobsville before, but not that many. And, what is zircons used for? Well, when we pull zircons from undeformed igneous rocks like we have in the Oronto group, to include the Frida, we can directly date those. And the Frida has a felsite intrusion in it known as the Bear Lake Stock, which has been dated to 1.062 billion years. So that still puts it within the Mesoproterozoic, barely. So this would be pre-Snowball Earth. So that one, has an igneous intrusion. The Jacobsville is not known to have any, although it may somewhere. We've never found that. So, but we can pull zircons from sedimentary rocks, but you can't get the actual age of the sedimentary rock from the zircons, because the zircons have been transported by streams or, other, wind, whatever, to get to where they are. And the Jacobsville is mostly terrestrial deposit. That means it's not marine, okay? And it extends all the way from Canada and, east end of Lake Superior, through the UP, through Wisconsin, and possibly into Minnesota and Iowa. The stratigraphy kind of breaks down there, but there are sedimentary equivalents there. So it's a huge terrestrial deposit. Okay, well, the zircons. Well, I always assumed the Jacobsville, there's an unconformity above the Frida, and I just assumed that the Jacobsville was shortly thereafter, maybe 20, 50 million years after, still within the Mesoproterozoic. I was wrong. Turns out the youngest zircons are about 900 million years old. Okay? Now, what's that say? Well, there's all other clusters too. I believe there's a cluster at 1 billion, at 1.2 billion, and like 1 point, or maybe 2 and 2 billion, maybe. But those don't matter for the age of the formation. That'll tell you where those zircons were derived from. But the formation, being sedimentary, can only be as old as its youngest zircon, which in this case is around 900 million years old. And it's not like we just have one outlier of this 900 million. There's a lot of them that fall into that age range. So the Jacobsville has to be younger than 900 million years old. What does this have to do with Snowball Earth? Well, the most Snowball Earth scenarios have been proposed for other Precambrian glaciations too, including the Paleoproterozoic one at 2.4 billion years ago. But we're just going to address the one that supposedly happened during the Neoproterozoic at the end of the Precambrian. And I believe that one was supposedly supposed to happen, was it 700 million years ago, I believe? Somewhere around there. Okay. Well, if the Jacobsville started being deposited at 900 million years ago, and it's thick. The group is on the order of thousands of meters thick. Okay? So it could have been deposited in like 20 million years, but it isn't likely. It probably was a lot longer, maybe on the order of 100 million years. But it could have been deposited any time between 900 and the beginning of the Cambrian, 541 million years ago. So, at Snowball Earth, if that was supposed to happen around 700 million years ago, we start running into a problem because the Jacobsville shows zero evidence of glaciation. None. And through paleomagnetism, which was also done recently, we know that the Oronto and Jacobsville groups were deposited. Well, the Oronto may not have been the beginning, but the Jacobsville was near the equator when it was deposited. Okay. Snowball Earth hypothesis says the whole Earth was frozen over. Well, that poses a problem, especially for something as thick as the Jacobsville and a terrestrial deposit. If Snowball Earth happened, we should see glacial deposits in it, and we don't. There's none anywhere. It's all stream and wind-blown deposits with minor lake deposits. Okay? So I don't buy Snowball Earth. I had quite my questions about it before this evidence came out, but now that we have the age of the Jacobsville at least framed between the Cambrian and 900 million years ago, that throws a huge monkey wrench into it. And like I said, the Jacobsville isn't just like a local deposit that could be, well, the rest could have been eroded or whatever. It is literally thousands of kilometers in its area of distribution and several thousand meters thick. So you can't blow it off. Okay? So, but there's a lot of ideas in geology I don't accept, and that's a big one. But anyway, that's my rant for today, and I hope you